In this video I will show you how you can invert a 4x4 matrix by using the cross product. Let's take a look at the following example. This here. We want to invert the matrix A. The first thing we have to do is to expand the matrix A with the unit matrix. So here on the right we write the unit matrix. So 1, 1, 1, 1. And the entries I left empty are just 0. I will not write the 0 entries down. So here we have the unit matrix. Now we will pick two rows of this matrix. For example, the first row and the second row. And then we will write these two rows down again. Like this. 1, 0, 1, 0, 1, 0, 0, 0. This is the first row. And the second row. 0, 1, 1, 0, 0, 1, 0, 0. And this here is the second row. Now we choose a 2x2 submatrix inside of this new matrix here that has a non-zero determinant. For example, we can choose this submatrix here. So this submatrix here has a non-zero determinant because the determinant is 1. Now we have to calculate some cross products. At first we pick the first row, this here, under the submatrix. So we pick this row here. We will ignore the rest of the matrix. So all of this here under the row will be ignored. So let's erase it. And now we will calculate the cross product of these two vectors in R3. And we will write the results in another matrix. So we ignore all this here and will calculate the cross products of these two vectors in R3. So for the first entry here, we ignore this here and calculate 0 times 1 minus 1 times 1 is minus 1. For the second entry here, we have to calculate 0 times 1 minus 1 times 1 is minus 1. And for the last entry here, we have to ignore this here and calculate 1 times 1 minus 0 times 0 is 1. And for all the other entries here, we just add a 0. Now we can cross out the row we just used. So we will cross this row out. And then we can pick the next row. So we will pick this row here. 0 and 0. And now we will do the same thing as before. So we have to calculate the cross product of these two vectors in R3, and we will ignore the rest of the matrix. So everything that is below this picked row here. So we'll calculate the cross product of these two vectors in R3, and the results will be written in the next column of this matrix here. So for the first entry of the cross product, we have to calculate 0 times 0 minus 0 times 1, which is 0. For the next entry, we have to ignore this here and calculate 0 times 0 minus 1 times 0, which is 0. And for the last entry, we have to ignore this here and calculate 1 times 1 minus 0 times 0, which is 1. And for all the other entries here, we will just add 0 as before. Now we cross out the row, like that, and pick the next one. So this here. And we will do the same thing as before. So we calculate the cross products of these two vectors in R3, and we'll write the results in the third column. So for the first entry, we have to ignore this row here and calculate 0 times 0 minus 1 times 1 is minus 1. For the second entry, we have to ignore this here and calculate 0 times 1 minus 1 times 0 is 0. And for the last entry here, we have to ignore this here and calculate 1 times 1 minus 0 times 0 is 1. And all the other entries here will be 0, as before. So now we will cross out this row and pick the next one and calculate the cross products. So for the first entry, we ignore this here and we have to calculate 0 times 1 minus 0 times 1 is 0. For the second entry, we ignore this here and calculate 0 times 0 minus 1 times 1 is minus 1. And for this entry, we have 1. And all the other entries are 0. And here is also 0. All entries down here are 0. And we cross this row out. So, and these cross products for these two rows here, when we pick them, we have already calculated, because these rows are the same as the second row here. So we already know when calculating these cross products that in this entry here is 1 and all the other entries are 0. So we just have something like this here, 1 and 1, and all the rest of the entries are 0. When you have problems applying this approach, you can watch my other videos about the cross product, or you can also buy my guide about the cross product where you will find a step-by-step explanation of this approach here. Okay, we will call this new matrix here we just calculated X. So this matrix here is X. The next thing we have to do is to insert the columns of X, so of this matrix here, in the matrix A. So we will insert the columns of X, so the first column, second column, third column, and so on, in the extended matrix A. When inserting in the first two rows of this matrix here, so the first row and the second row, this should always yield 0. So we will ignore these 0 entries. So the only thing we have to do is to insert the columns of X in the third row here and in the fourth row here. Okay, let's start by inserting the first column in the extended matrix. So in the third row of the extended matrix and the fourth row. So we will get -1 times 1 plus -1 times 1 plus 1 times 0 is -2. -1 times 1 plus -1 times 1 plus 1 times 1 is -1. So now we are done with the first column, so we will insert the second column. This is pretty easy because it's a unit vector. So we get 1 and 0. 1, 0. So now the third column, -1 times 1 is -1. And here we get +1 times 0, which we can ignore. And here we have the same thing, -1. Now the fourth column here, which is -1, -1, because here we have 0, 0, -1, -1, and these two columns here are unit vectors again, so this is pretty easy. We have 1, 0 and 0, 1. So now we have this matrix here. Now we will write down the rows of this newly calculated matrix again. So the first row, which is -2, 1, -1, -1, 1, 0. So this here is the first row, and then we will write down the second row, which is -1, 0, -1. And -1, 0, 1. So this here is the second row. And now we have to calculate some cross products again. But at first we have to choose a submatrix, a 2 times 2 submatrix inside of this matrix here. This time it shouldn't matter at all if the determinant of this matrix here, of this submatrix, is 0 or not. So we can just choose this submatrix here all the time, because it shouldn't matter what determinant this matrix has. Okay, and now we calculate the cross products as before. So we pick the first row under the submatrix here, so this here, and we will ignore the rest of the matrix, and then we calculate the cross products of these two vectors here in R3, and we will write the results in the first column of this matrix here. So here. So for the first entry we have to ignore this here and calculate 1 times -1 minus -1 times 0 is -1. For the second entry we ignore this here and calculate -1 times -1 plus 2 times 1 is no, -1 times -1 minus 2 times 1 is -1. And for the last entry here we have to ignore this here and calculate -2 times 0 minus -1 times -1 is 1. And all other entries will be 0. 0, 0, 0. Now we will cross out this row here and pick the next one, this here, and we'll calculate the cross product again. So for the first entry we have to ignore this here and calculate 1 times -1, and here we have a 0, so -1. For the second entry we ignore this here and calculate 1 minus 2 is -1. Here we have 0, and this here is 1 again. Okay, crossing out the row and picking the next one. So cross product again, we ignore this here and calculate 1 times 0 minus 1 times 0 is 0. We ignore this here and calculate -1 times 1 is -1. And here we have a 0. And 0, 0, 1 again. 0. Okay, cross out the row. And then the last time we have to ignore this here and calculate 1 times 1 is 1. Ignore this here, -1, 0, 2. And 0, 0, 0, 1. And now we have this matrix here. The next thing we have to do is to insert the columns of this matrix here in the matrix X. So we will need the matrix X again. And we have to insert the columns of this matrix here in the matrix X. So let's do this. So the first column, so we get -1 times -1 is 1, plus 0 times -1, plus 1 times -1, which is 0. So -1 times -1, and here we have 0, 0, so we get 1. So inserting here, we have -1 times 1, which is -1, and -1 again. And here we have -1 times 0, -1 times 0, and 1 times 1 is 1. And all other entries are 0. So 0, 0, and 0. Okay, the next column here, we will insert it in the matrix X. So -1 times -1, 0, 0, which yields 1. -1 times -1 is 1, -1, which is 0. So we have -1 times -1 is -1. -1 times 0, -1. And 0, 1. 0 and 0. Okay, third column, we have 0 times -1. This should yield 0. Then we have 0 is 0 again. We have 0 and -1. And 0, 0, 1, 0. Okay, and now the last column, inserting an X yields us 1 times -1. So -1. 1 times -1, so -1. 1 times 1, so 1. 2. And here we have 0, 0, 0, 0, and 1. Now we have calculated this matrix here, and we will take a look at this submatrix here, and we will also take a look at these numbers here. As a last step, we now have to multiply the columns of this matrix here with a number so that here will be -1. So we have to multiply the first column with the number -1. So here stands -1, +1, +1, -1. We have to multiply the second column with -1 so that here is -1, +1, +1, -1. We have to multiply the third column with -1 so that here is -1, +1. And we have to multiply the last with -1 so that here is -1. Here we have -2, -1, +1, +1. And in the end, here should be the negative unit matrix. So you have to multiply every column with a number so that here is the negative unit matrix. And the matrix that is up here will be the inverse of the matrix A. So this matrix here is now the inverse of the matrix A. And we are done.